Okay, thank you so much. Thank you everybody for attending and for your patience while we got this all set up. It is my great pleasure to be here today in a master up room, but we've got a growing list of attendees and we will get the seminar started shortly. Rachel is, our speaker is here with me, but I just wanted to take a few moments before we start to say a few things about artificial intelligence at UQ, the growing interest nationally, globally, and what kind of activities and research and collaborations that are happening at UQ, and then we will get started with the seminar. So I'll take a minute to just talk about what's happening, more nationally. I think we all recognize what is happening internationally, and there's been a lot of buzz, sometimes a bit of hype, hey, Rachel, around artificial intelligence. But earlier this year, actually just a few weeks ago, the Australian federal government, in the most recent budget, put in around 1.2 billion on Australia's digital economy, and a big part of that actually has been allocated to what they call Australia's AI Action Plan. So we very welcome. So those of us who've been in the area, either from computer science or from many adjunct aspects of artificial intelligence, really welcome this move by the government. There is a few initiatives that are happening around it, at a national level, and UQ definitely is going to play a part. We will do our bit in making sure that those objectives are being met. So that is something I wanted to bring to everybody's attention, and then talking a little bit more at home in regards to what is happening at UQ. So I'm just putting in a URL on the top over there, artificial-intelligence uq.edu.au. For those of you who've maybe not visited this site, I'd really encourage you to go and have a look. It just projects and provides a single website where you can see the diversity of work that is happening in UQ around AI. So this includes not just the core areas like the technical areas around AI, but also a lot of the adjunct areas around, the social science and the business, and all of our domain areas like mining, agriculture, health, and energy and business, and so on. So it's very comprehensive. We've got about 100 plus people who are profiled over there. So I hope that especially people in the audience who are from outside of UQ, I hope that gives you some indication of the work that is happening at UQ. And more recently, just in fact, a few weeks ago, also, UQ has invested into what we call UQ AI Collaboratory. It brings together, again, about 30, 40 people from across the board. We are working towards a strong and, visible knowledge leader and trusted partner in AI, and data science and machine learning, of course, go hand in hand very much with that. So we're looking forward to kicking off some of those projects. They are primarily focused in health and medicine, but also in society and government. And I know Rachel is going to talk about the implications for society. Just watch this space, and we hope to share with you some of those projects and the results coming from those projects very soon. Now, that was all about AI at UQ, and now it's of course my great pleasure to kick off this activity with an inaugural seminar from our speaker, Rachel Thomas, getting specific about algorithmic bias. So Rachel is a new acquisition by Australia, if I can say, coming in from the West Coast US. And those of you who are familiar with the AI landscape would be very familiar with Fast.ai, which is one of the, if not the most popular free online course on deep learning, which Rachel is looking after together with Jeremy Howard. Rachel was previously founding director of the Center for Applied Data Ethics at the University of San Francisco, so before coming to Brisbane. And the focus there was on issues of surveillance, disinformation, bias, justice in the tech industry. Rachel, you earned your PhD in mathematics at Duke University, early data scientist and software engineer at Uber, has been selected by Forbes as one of the 20 incredible women in AI, and was profiled in the book Women Tech Founders on the Rise. So with that, please join me in welcoming Rachel. Rachel, welcome. So I'll stop sharing. Thanks so much. There we go.
Awesome, thank you. Let me adjust this camera. Yeah, so yeah, hello to everyone here. Thanks so much for having me here at UQ, and hello to everyone that's tuning in online. Apologies, as I was preparing, I ended up iterating through a few different titles and abstracts because I did really want to kind of gear it to this audience. So my updated talk is the opportunities and perils of AI, because I did want to spend a little bit more time on the positives and some of the research Shazia was mentioning here at UQ of positive applications of AI. But then I also do want to talk about what potentially can go wrong, and kind of practical steps towards solutions and towards more responsible kind of development and deployment of AI. Please let me know if also if you have any trouble hearing me, and I am really excited for the discussion afterwards. Then let me see. Okay, I'm just going to slide my laptop over so I can advance the slides more easily. Oh, there we go. Let me just. Okay. And then, yeah, thank you for the warm introduction, Shazia. So you kind of already covered my background fully, so I don't need to go through that again. But I've kind of worked on a bunch of different things within the math and data science and AI and ethics space over the years. And I have now moved to Brisbane permanently. My partner, Jeremy Howard, is an Australian citizen who had been wanting to come home for years, and we really think that Queensland is the best place to raise our daughter. So this is kind of a permanent move. We're here for the long haul, and excited to be here. So I believe AI holds a lot of opportunity, and this is why I co-founded Fast AI. Yes, 5 years ago now, but even before that, kind of saw the huge potential of deep learning to transform many industries. Just briefly, Fast AI is a nonprofit research lab trying to make deep learning more accessible and easier to use. We have a free online course with no ads, and it is take students to the state of the art, and it's incredibly practical and hands-on and applied. And I want to share the stories of just a few of our students, and I should say most of our students are adult working professionals looking to kind of better leverage AI in their current careers or to switch careers. And part of our vision is to really reach experts in other domains, as well as people kind of outside, people with non-traditional backgrounds and who haven't necessarily been included in a lot of kind of AI education, which traditionally has been kind of very academic and very much housed in elite computer science departments. So one of our students, Elena Harley, is applying deep learning to improving cancer treatments. And she's written a really great series of blog posts on some of her work, identifying kind of tumor variants, as well as identifying the state of origin for metastasized cancer, of kind of where in the body it originated. These are all kind of very important questions for treatment. And here she's talking about an experiment where, in using deep learning learning and using the FastAI library, she was able to improve the state of the art from she started off with this false positive rate of 28% and got that down to 7%. So kind of a huge improvement in accuracy. And I know Shazia mentioned kind of some of the medical research happening here at UQ as well, that this is a very high potential area. And Helena is just one of several students I wrote about in a blog post of some kind of interesting and promising and also unconventional applications of AI. Another comes from a Canadian dairy farmer named Corey Spencer. And Corey and his partner farm goats. And a big issue in the goat dairy industry is that goats can get udder infections that cause permanent damage to their udders before they're even detected. And so Corey developed a new technique using heat sensors to identify an udder infection before it was visible to the human eye and before they were previously being diagnosed, to start treatment earlier and prevent this damage. And he has spun this off into or commercialized this into a company, and is now working on other applications of goat udders. And to me, this really captures why I want people from kind of all domains to understand deep learning, because I think you know about problems that nobody else knows about. And this is an application that never would have occurred to me. I don't know anything about goat udders, but it really kind of captures the power that's there with deep learning. And a third student I'll mention is Helena Siren. And actually, I should update this. Her new Twitter handle is at Neural Bricolage. And she is doing some really innovative and beautiful work in the area of generative art. Something that's particularly distinctive about her art is that, so she's both an artist and a computer programmer. And so she creates her data sets. That is, she is doing all the painting and pastel and photography to create the art. And then she's also writing the code in the neural networks to generate new art from the art data set that she created. And so she has a very distinctive style, and is kind of controlling all levels of her process. It's like she is kind of building the tools that she as an artist wants, and is really kind of receiving more and more recognition for her work, which is very well founded. You should definitely check it out. And I love, she has an interview, why bigger isn't always better, with GANs and AI art. She has another, I should have included it, one of the co-founders of OpenAI was saying how he likes to just train really big networks on giant computers. And she says, I like training on a single computer on a small data set. I'm a sophisticated woman. And I love that spirit, and it's kind of very similar with what we're going for with FastAI, of really wanting to make deep learning accessible to people with a single computer, a single GPU, with a small data set. And not just for it to be accessible, but to recognize that that can be an advantage, that constraints drive creativity and they drive innovation. And so we were able to put that to the test in a different context, which is a speed test hosted by Stanford called DawnBench. And so this was a competition to train ImageNet to a set accuracy the fastest. So not just kind of who can reach, like eke out that last 0.1% on ImageNet, but to do it very quickly and to do it cheaply. And so a group of FastAI students went up against teams from Google and Intel that had access to way more resources. And FastAI achieved, at the time of the competition, the lowest actual cost. They were fastest on GPUs, fastest on a single machine, fastest on publicly available infrastructure, and faster than Intel's entry that used 128 machines. So I'm super proud of the work that the team did on this. And it really was this example of constraints driving creativity. And I think that sometimes at the large tech companies, they kind of just get into a mindset of, throwing more money at a problem and throwing kind of even more GPUs or TPUs at the problem. as opposed to thinking of and some of the things the FastAI team did seem simple in hindsight, and many of them were later adapted by Google and Intel and NVIDIA. But to kind of have that spur on for creativity. At the time of the competition, the one entry that beat us was Google's entry on a TPU, and TPUs were very new then, so they were not commercially available. Like you couldn't rent one even if you wanted to. But FastAI came back 4 months later and released results that were 40% faster than the TPU results at the time. And this was covered by The Verge and the MIT Tech Review, and then also kind of all the techniques that FastAI used. We both incorporated into the FastAI software library, as well as kind of openly shared. All right, so that's kind of, I think, some of the promise that AI holds, but what can go wrong? And as I think we've all seen, there are several things that can go wrong when AI is kind of not responsibly deployed. And I'm going to talk about 3 areas, and then move into some kind of practical steps towards addressing them and towards being responsible in our development. So the first is unjust bias. This shows up a lot of places. So going back to medicine, there was a study in the Proceedings of the National Academy of Sciences that was looking at chest X-rays and varied the gender composition. So they, trained a neural network on kind of all male chest X-rays as well as on all female. And they were looking for a number of lung conditions. And for a gender imbalance training set, they got far worse performance on the opposite gender, whichever one hadn't been represented. And it was even a somewhat surprising result, or perhaps not surprising, but many of the conditions didn't even necessarily seem like they would directly relate to gender, but there really was a significant difference. And so bias can show up in many places. In the US, we've had examples with facial recognition, and particularly facial recognition tools. There now, several companies have moratoriums on them, and a number of big cities have bans, but for a while they were being sold to police, and actually they still are being sold to police by some companies and in many locations, kind of totally untested, unregulated. And so one study found that technology Amazon was selling to police departments incorrectly matched 28 members of the US Congress to criminal mugshots. So this was kind of huge error, and the Congress people that were wrongly matched to these mugshots disproportionately included people of color. So this is something that has potential for disaster to be doing this. And then I'm trying to get more up to speed on kind of how this might take place in the Australian context. And so there is a study from New South Wales on the suspect target management plan, and this is by researchers in New South Wales. And this is a program by police there that has an algorithmic component and was found to disproportionately be targeting Aboriginal youth. And so kind of having this biased outcome. It was also shown to not actually being preventing crime, but really just kind of harassing and alienating Aboriginal youth in the process. So unjust bias is one big area. Another big area to know about is feedback loops. Feedback loops occur whenever the model you build is controlling the next round of data that you get. And so we see this with recommendation systems where they may end up recommending really toxic conspiracy theories that can have sway in elections or promote hate speech or violence, and where they're kind of not just predicting that someone will like it, but also introducing that material and helping it grow in popularity and snowball. And this kind of same dynamic with feedback loops is also present in predictive policing. And actually, I'll talk more about this in a moment. Predictive, yeah, I'll get into that. So I'm just kind of going through these and I'll go into a little more detail. A third area that concerns me is that errors can really happen at scale with automation. That when you make a mistake, that mistake can really be impacting a much larger group of people than it might prior to automation. And this is something that AI is accelerating even more. And so we see that with robo-debt, and robo-debt, to be clear, did not use AI, but it was an automated process that impacted over 600,000 people and caused a huge amount of trauma and harm. And we also see that, and I'll talk about this a little bit more, but Facebook's role in the genocide in Myanmar, and that's something that the UN has found that Facebook did play a determining role there, and that Facebook ignored kind of years worth of warnings from locals that were on the ground saying like this, this platform is really being used to incite ethnic violence, and so this can happen at kind of a very big scale. And so these ethical issues increasingly became my focus over the past few years. And I was the founding director of a Center for Applied Data Ethics at the University of San Francisco. And really, they've captured my attention because I think they are so urgent and so important for us to be addressing. I did have to leave this position with the move to Queensland. So I want to kind of ground this in a very specific example, and so dive a little bit deeper into facial recognition, which I mentioned earlier. So the gender shade studies by Joy Balamwini and Timnit Gebru has rightfully received a lot of recognition. It's something that I think really changed the field and brought a lot of attention to this issue. And what this study was, it looked at commercial computer vision applications. So these were things that had made it into production and had been released as products. And they found that across many companies, there was a much higher error rate on dark-skinned women. And so basically error rates were higher on women than on men. They were higher on people with dark skin compared to people with light skin. But for instance, IBM, and this is a typical example, had 99.7% accuracy on light-skinned men, compared to only 65% accuracy on dark-skinned women. And this is kind of completely unacceptable to have in a commercially released product. So Amazon also was selling facial recognition technology with this disproportionately high error rate. Some of these technologies were in use by police departments, and Amazon has a moratorium now, but there's still other companies that are selling to police departments. And so this is an area of huge concern. And so kind of digging into part of the roots of it, it comes down to partially to training sets. And a lot of the key training sets for facial recognition 10 to 15 years ago largely consisted of pictures of light-skinned men. And so that's kind of part of how this arrived. And so more representative data sets are a great step towards, it's definitely something you should be thinking about in your models of how representative your data set is of the population that will be impacted by your model. So while this is important, some people have kind of gotten an incomplete message of this is enough. And so kind of going back to my first title of diverse data sets are not enough, this is actually not the stopping point. So definitely think about representation when you're putting together a data set, or even when you're just evaluating somebody else's model or evaluating a product that someone is pitching to you, the representation in the data set is important. However, kind of continuing with this, and Joy Balamwini and Timnit Gebru and Deb Raji, the Gender Shades authors, have been very clear on this from the beginning that this is insufficient. In the US, you also have to look, and not just in the US, in any country, you have to look at how this technology is being used. And so in the US, there are numerous cases where police have used facial recognition to identify Black protesters who were protesting the wrongful murders of Black people killed by police with impunity. And so this is something that I find kind of quite chilling, the idea of recognizing protesters. And it's something that we have to think about our values in a democratic society of, what does it mean to recognize and arrest protesters, and how that kind of tips power. And that's really getting at also kind of what are the underlying uses and motivations of a technology. And this is something that is, not resolved by having a more diverse data set, because that would just kind of be improving your facial recognition to be more accurate. But when you're using it for an unjust purpose, accuracy doesn't make it ethical. And so Dr. Gebru had a great quote about this in the New York Times. She said, a lot of times people are talking about bias in the sense of equalizing performance across groups. They're not thinking about the underlying foundation, whether a task should exist in the first place, who creates it, who will deploy it on which population, who owns the data, and how is it used. And these are all really important and crucial questions to be asking that are part of bias, and that go much deeper than a kind of just evaluating it on different subgroups. So that's so I kind of wanted to kind of go deep on this case study, just to kind of ground our conversation. But I want to pause here and address the question of why the fuss about algorithmic harms. And so I have given a number of talks, and I've taught classes where I talk about algorithmic bias and other algorithmic harms. And I've gotten many variations of kind of a question, humans are biased too. This is incredibly well documented that humans are biased. So why is it this huge problem that algorithms are biased? And similarly, humans make mistakes. Why all the fuss about algorithmic harms? Aren't we just kind of encoding what humans already are doing? And I do think that algorithmic harms are significant, but I want to kind of share some of the reasons why. The first is that machine learning doesn't just encode bias, but it can amplify it. And there are several studies that have shown this. One looked at people's kind of descriptions on LinkedIn, and it found that when you start with a kind of very imbalanced data set, so for instance, one of the groups they looked at were surgeons, and in their training set, only 14% of the surgeons were women to begin with. And then those balances compounded, and it's kind of like this asymmetry between false positives and false negatives, and they ended up with just 11% female surgeons in their true positives. And so you can end up with a model that is even more biased than your original training set. So there's this amplification that is possible. And then, as I mentioned earlier, feedback loops. So your model is not just observing the world how it is, but it's often controlling the next round of data you get. And I think this sometimes gets obscured, even with the title of data scientist. And many of us in data science kind of came from, a STEM research background, and you often think of, conducting an experiment and observing. But anytime you are kind of creating a model that is then put in use, particularly if that's released as a product, you're also controlling what the next round of data you get is, because it's kind of an actor in the world. And this is what happens with feedback loops. And so we've seen a lot of attention to the role that Facebook has played in a lot of online radicalization into kind of very harmful conspiracy theories, many of which are anti-science, or kind of a hate-based. There's also an example where Facebook's recommendation system was kind of putting together playlists for pedophiles. And so it was taking, and this was covered by the New York Times in a big investigation. And this also had occurred in France previously, although didn't get as much attention until it happened in the US and was covered by the New York Times. But that they would take kind of, and this was happening algorithmically, it wasn't intentional, but the algorithm was selecting these videos that someone had just uploaded kind of an innocent home video that happened to have a young girl in a bathing suit or in a leotard, and was kind of stringing these together in these playlists that were then getting, surprisingly large numbers of views. And so you can have these very kind of undesirable consequences. Yes. Sure. No, I can't. Let me. I'll just. You want it to read that? Sure, I'll read the question out. So it says, enabling anyone to use AI certainly has benefits, but it may also lead to its misuse. This is somehow similar to the gun control controversial topic if we see AI as a weapon. So do you think we should allow everyone to own and go around with guns? Should we have a driving license to use AI? So this is a great question. So part of the issue, or something that's important to me, is to recognize that there are people that are very kind of highly trained, who got their PhDs at very prestigious institutions, who are creating and obviously not everyone, but who are creating very harmful applications of technology. And so I have not seen a correlation that, going to, the most prestigious computer science program and having a PhD correlates with being more ethical, or with not developing harmful technology. And right now, kind of the people that have the most elite training are largely a homogeneous group. So there was a study by Element AI that of AI researchers, I believe only 12% are women. It's kind of incredibly imbalanced. Racially, it's, I think, even more extreme. It's a overwhelmingly white and perhaps Asian field, but there's a real kind of lack of racial diversity. And so I do, in terms of the question of kind of wanting more people to have access to AI, a lot of that is about wanting to diversify the field and to recognize kind of the value that having a diverse field brings, both in kind of responsible use and also in addressing the harms and misuses. And I'll talk about this a little bit more later. And I certainly, I think there's good in efforts around developing standardization and also regulation, I think plays a role. And so I'm definitely in favor of thoughtful regulation. And I know there are kind of efforts around, like what should we have code of ethics? And I think that, that certainly won't solve the problem on its own, but can be a useful component. So I think it has the potential to be dangerous, but I think, the potential to be very dangerous, but I also think that part of addressing that means getting more people from other backgrounds who understand the technology and can get involved with it. And another huge area, and I'll get to this a bit later on too, is I think having more people from the social sciences and humanities who understand AI, because I think those fields bring very, very important perspectives that we need towards addressing this. And so I think kind of starting from a place of really limiting who can use AI, I worry is going to preserve the status quo, which is already kind of quite harmful of having a homogeneous group. But that's a great question. Thank you. So going back to this. So feedback loops. Another area where we see feedback loops, I mentioned this earlier, is predictive policing. And so predictive policing is more common in the US and the UK, although as I mentioned, there's a little bit that's happened, particularly in New South Wales. And the idea is that you are have a computer program that is kind of telling police which neighborhoods they should send more police to, and which neighborhoods should receive kind of fewer police officers. And the thing is, this is kind of helping create an outcome. If you send a bunch of police to a neighborhood, it's likely that they will make more arrests. Whereas, if there are no police in a neighborhood, they're not going to arrest anybody there. That data can get fed back into the algorithm and say, oh, you're making a lot of arrests in this neighborhood. Maybe you should send even more police there, and can have this amplifying effect. One researcher who works on this, Suresh Venkatasubrahmanian, has said predictive policing is aptly named. It's predicting future policing, not future crime. And that's something we see a lot of, kind of this also confusing proxies, where you start using kind of arrest as a proxy for crime. So feedback loops are, and again, this is kind of all under this umbrella of why worry about algorithmic harms, and one of the reasons is feedback loops. And then this third area is, or not third area, but this area of mistakes happening at scale and without an appeals process. And so a really chilling story from the US is there's a algorithm that's used to determine people's healthcare benefits. And these are kind of state healthcare benefits. And when it was implemented in the US state of Arkansas, there was a bug in the code that incorrectly cut benefits for people with cerebral palsy. And it did this in a very drastic way. And so people such as Tammy Dobbs, pictured here, who need a home health aide to help her get out of bed in the morning, to go to the toilet, to get her breakfast, for kind of very, very important kind of basic quality of life, had this drastic cut in care. And very concerningly, she wasn't given any explanation about the cut. And I think even more significantly, no way to appeal it. There was kind of no straightforward way to say, hey, I think this is wrong and I need more care reinstated. And eventually this came out in a lengthy court case of, oh, hey, there was a bug in the code. But unfortunately, this is too common, this kind of instituting a computer process with no way to catch or identify mistakes. One other example I'll share, this is from the UK, and kind of very disturbing, but the post office, I think for like 20 years, was using accounting software that had bugs, and over, I think it was over 800 post office employees were prosecuted. So they were accused of embezzling funds because this buggy accounting software was showing budget shortfalls. Many of them did jail sentences. People's lives were destroyed over this. Some of them lost their houses or their marriages. And now the UK government has gone back and said, oh, this was an error, but at this point it was in many cases 10 or 15 years ago that this happened, and so this is sadly too common, this pattern of not having a way to identify or address errors. And all this kind of illustrates that algorithms are often used differently than human decision makers. And so I think kind of too often we talk about them as though they're plug and play, interchangeable, of, you can take this decision that was being made by a human before and then just plug in an algorithm and everything else is going to be the same. And that's not the case. People are more likely to assume that algorithms are objective or error-free, and so even if you give them the option to override the decision, they'll often say like, "Oh, it's from a computer; it must be objective." As I mentioned, algorithms are more likely to be implemented with no appeals process. They're often used at scale, and they're cheap. And these factors all relate to each other. If you're trying to do something cheaply at scale, having an appeals process and putting those safeguards in place to really be on the lookout for mistakes, those things do cost more money, but I think they are more in line with the values that I hope we want as a society. And so I wanted to give a shout out now to the work of Paul Henman, who's a professor here at UQ, and his background is in both computer science and sociology. And he was really kind of ahead of the game. He has been studying what happens when governments digitize their services for decades, and has written about this, and has observed that computerization does not result in the same organization by different means, but that it really changes what the organization does. And so kind of recognizing, you're not just changing this one decision or this one process, but it's often part of a much larger change. And one of the examples he talks about in some of his work is robo-debt, which happened here in Australia, and this is where the government, instituted what they said was kind of a new automated way of checking for people that they thought had cheated the welfare system, but it also it kind of assumed that someone's income was perfectly even for the whole year, which is not a good assumption and not true for many people, and then would automatically generate debts for people. And this was ruled to be unlawful, but it impacted over 600,000 people, and many people, spent years kind of thinking that they were thousands or tens of thousands of dollars in debt, getting calls from debt collectors several times a day. And this is also kind of an example of this scaling, because I believe prior to this, the government had been pursuing, I think it was 20,000 cases a year of what they saw as discrepancies, and they escalated that to 20,000 cases per week. And so we're kind of able to pursue people at this very, very high scale. So kind of going back to this question I asked, why this fuss about algorithmic harms? These are the reasons why I think it is important to focus on algorithmic harms, and why they're not just a direct analog of when humans are biased or when humans make mistakes. And that comes down to the role of feedback loops, the opportunity to amplify and not just encode bias, that they can be used at a massive scale very cheaply. They can be used or they can be implemented with no way to identify mistakes. And so all this kind of leads me towards something I have been thinking about a lot in the last year, which is that it's very crucial that the people most impacted have avenues for participation and power. Because I think some people would see these harms and would say, okay, the solution is we need to educate engineers on ethics. And I think that's totally important, and that's one component. And I even back at USF, we added like a mandatory data ethics class to the curriculum, and I taught that, and I really support those sorts of efforts, but that's not sufficient on its own. We also really need to get people, the people who will be impacted, closely involved. And so this kind of getting to the question that was asked earlier from the audience, I believe that ethics issues really underscore why we need everyone involved, and that includes racial and gender and geographic diversity as well. In particular, I think the US is home to kind of all these major tech companies that are deploying products all over the world, often in cultural contexts that are not well represented or well understood by the companies. So diversity, the importance of domain expertise. Like I want lawyers and medical doctors and nurses and people from kind of all different domains to understand this technology and to understand what it can and cannot do, and what it should and should not do. As I mentioned earlier, the humanities and social sciences have a lot to teach us about kind of different ways of understanding these systems, and really crucial ways of understanding these systems. I also think increasingly that we, kind of everyone in society, will need a level of AI literacy, as it is included in so many more products and services. Also to just even screen out some really great innovations, and there's also some total snake oil, and for people to know even what is a reasonable claim, and is this product going to do what the marketing around it says that it does. So I do think we need kind of a baseline understanding around AI. Yeah, and these are kind of more examples of how I think the people impacted often saw the problem first and earliest. I mentioned the genocide in Myanmar earlier. That's something where as early as 2013, so kind of long before it was had reached the stage of genocide, there were people in local nonprofits who were warning Facebook execs, the platform is being used to incite ethnic violence and to spread dehumanizing hate speech. And kind of really saw it early. There's also an example from early 2014 on Twitter, a group of Black women that were able, these were just users of Twitter, who were able to kind of unmask this whole campaign of Twitter trolls that were using fake profile pictures, and they found, the message boards where the trolls had kind of planned this, and really kind of tried to raise an alarm, and even also point out, like, this is how we were able to recognize that these accounts were inauthentic and engaging in this inauthentic coordinated activity. that people close to the problem can often see it earliest. And so this is a recurring problem, but unfortunately those people often have the least power. And even though they recognize issues early, they too often are not listened to. And they also best understand the needed interventions, and they understand what interventions are likely to work, and which ones might actually make things worse, even if they're well intentioned. Kind of I guess, more positive example of this happening would be Tracy Cho, who was an early engineer at both Quora and Pinterest, and is now founder of Block Party. And she says the first feature she built when she worked at Quora was the block button, and I think this is when they had like only 5 employees. And she said she was eager to work on the feature because she felt like she was being antagonized and abused on the site, and that if she hadn't been there, she says they probably wouldn't have added block nearly as early as they did. And so this is kind of a positive example of how having some diversity can help address problems earlier. One of my favorite events last year, which I attended virtually, of course, with the pandemic, was at ICML, which is a huge academic machine learning conference. There was a workshop on participatory approaches to machine learning. And you should check it out. All the papers and talks, I think, are available online. The call for the workshop I really loved. It acknowledged that the designers of machine learning system have a lot more power over the system, and that kind of too often, even when we are focusing on algorithmic fairness or human-centered machine learning, we're focusing on centralized solutions, which kind of keep the power still among those of us that are building and designing the systems. And so they made a call for more democratic, cooperative, and participatory machine learning systems. And so I thought that was a really beautiful phrasing. And there was a lot of great work was shared at this workshop. So I wanted to highlight that too often kind of even our solutions aren't getting at this kind of root problem of who's empowered within the system and whose perspectives are being included. Let me just check how I'm doing on time. All right, so I wanted to dive into. I always kind of want to have something concrete and practical too. Just some practices you could implement in your projects or in kind of in your startup or at your company. And the first is I want to give a shout out to the Markula Center at Santa Clara University. They have a lot of great resources available online. I use a lot of their resources when I teach data ethics, and in particular, I like their ethics toolkit. And it's a set of 7 or 8 practices. I'm not going to go through all of them. I'll just give you a flavor of kind of recommended practices you can implement at your company. And tool 3 is, they call it expanding the ethical circle. But it's really kind of walking through a set of questions around, whose interests, desires, skills, experiences, and values have we simply assumed rather than actually consulted, and really thinking about who, kind of getting at this participatory aspect of who has been included. And I won't go through all of them, but they have kind of a series of questions. They also talk about how to kind of how to schedule regular times where you're doing these sorts of reflections. And then I wanted to highlight here at UQ the Florence Project, which I've just talked to Dan Angus a bit about this from QUT, but I love the vision of this. And this is part of the ARC Center on the dynamics of language, but about to co-design with people who live with or support those living with dementia. And I think that's a really great vision to kind of be doing this co-designing with the people who are closest to the problem. And I love that framing. There's also a great resource from University of Washington Tech Policy Lab called Diverse Voices, and they go through kind of how you can assemble a panel of experts who have an experience that may not be represented at your company, and so they do examples where they have put together expert panels of people with disabilities, people who are formerly incarcerated, people who don't drive cars, people with extremely low incomes, and talk about how you can kind of do this panel and include that perspective in your work. And it's nice that they kind of have both, this was like an academic paper, but also a practical how-to guide. It is important, and I should say it is important that this happen genuinely. Kind of an example of what not to do comes from Sidewalk Labs, which is part of Google's Alphabet kind of umbrella. And at their project in Toronto, they held some indigenous consultations around their, this is for the kind of Sidewalk Labs Toronto project. And they released then a 1,500-page master plan. And in the master plan, they mentioned several times that they had done an Indigenous consultation, but they did not include any of the recommendations that came from that consultation in the plan. And so that's kind of an example of like, this is not just checking a box, it's not just holding the consultation, but really taking seriously the feedback. And there was a paper on this in the workshop I mentioned earlier about some of the risk with participation washing. And so this was not saying not to have participation, but to recognize some of the power dynamics of when can this lead towards participation washing. So I liked this paper as well. Going back to this Markula Center, their toolkit, another tool that this is the only other tool I'll highlight, although I encourage you to look it up and read it in full, is on closing the loop. And this is really about making sure that you have systems in place to get feedback so that you can iterate. And identifying those feedback channels and integrating them. And something I'm kind of most familiar still with kind of Silicon Valley and the San Francisco Bay Area, but in the San Francisco Bay Area with startups, not just startups, even with kind of big tech companies, often product and engineering is kind of a totally separate silo from what's called trust and safety. And trust and safety includes content moderation, it includes legal, includes customer support, to kind of anyone that's going to be hearing complaints or reports of abuse from customers. And often that feedback is really quite siloed away from the engineers and designers that are building the products. And this is a problem, and Alex Fierst highlighted this really well. He was previously chief legal officer of Medium and is now, I think, chief legal officer at Neuralink, highlighted this problem. And he kind of interviewed someone who works in trust and safety, saying this separation is a real problem because it needs to get baked into the product, and it can't kind of be this add-in of customer support or content moderation as this kind of like separate afterthought. And then there's also in Bay Area tech, there's also a real kind of level around this where product and engineering is kind of seen as superior, and trust and safety is viewed as lesser than, even though it is super crucial, and it really encompasses the people that are on the front lines, kind of hearing what's going wrong. And so I thought that was a nice, tangible observation, though, of let's kind of have more integration between these areas. And I also want to highlight, I tend to focus on, I'm really, think of myself as, I am a data scientist and come much more from the kind of working in the tech industry background and perspective, but that good practices in tech, at tech companies alone are not going to solve these problems. We do need we do need good policy as well. We need a regulatory component. And so going, kind of mentioning the genocide in Myanmar one more time, again, there were warnings going back to 2013, and it's not until 2018 that the UN found that Facebook had played this determining role. Somebody very close to it who had kind of tried to warn Facebook earlier said, this isn't 2020 hindsight. The scale of this problem was significant and was already apparent. And if you look at the numbers, I think in 2014, Facebook only had 2 content moderators that spoke Burmese, which is the primary language in Myanmar. And then in 2015, they upped it to maybe 4 content moderators, which is a very, very small number when you had kind of millions and millions of people on Facebook. And so just to contrast kind of how how Facebook responded to these escalating warnings about the potential for genocide. And one person even warned them in 2015 and said, you know, Facebook could play the role in Myanmar that the radio broadcast played in Rwanda. And if you're familiar with the Rwandan genocide, the radio broadcast played a very, very pivotal role there. And so, you know, then kind of, and this was even, I think now 2019, Zuckerberg said, okay, we'll try to hire dozens of Burmese language content reviewers, which is still a relatively small number. In contrast, Germany passed much stricter hate speech laws that potentially Facebook could have faced a penalty of up to 50 million euros. So kind of very huge and significant penalty. And Facebook hired 1,200 German content moderators in under a year. And so to me, and I'm not promoting the German law as something we should adapt, but just this contrast between kind of how many people were hired when it was warnings about genocide versus how many people were hired when it's the threat of a hefty fine. And so to me, this kind of shows an example of what Facebook responded to, what kind of got them to act. And it was regulation and the threat of a meaningful fine. And so, yeah, I'll just say, you know, I think we need policy and ethical industry behavior. Both are very important. Policy helps address negative externalities when you have misaligned incentives, also race to the bottom situations. But ethical behavior in industry is really necessary as well. And so I definitely support and have been a part of and hope to continue to be a part of training engineers around ethics, because the law is not always going to keep up. Edge cases will arise. And so I think that's crucial as well. Yeah, so just in summary, some kind of steps towards solutions are making sure you have ways to surface errors quickly, you know, and that awareness that things do go wrong and there are bugs, and can you catch those quickly. Offering timely and meaningful appeals to people impacted, meaningful consultation with voices that are often overlooked. Diversity in hiring, retention, and promotions, designing our products with contestability in mind, which is related to this kind of idea of appeals, integrating product and engineering with trust and safety, and supporting good policy. And so I wanted to, just kind of offer these as some, I think, concrete things that hopefully we can do to address these problems. And then I'll close with this slide I shared earlier that I really think these ethical issues underscore why we do need everybody involved with AI, and why I want to see the field more diverse and including people from all sorts of different domains, and also with a lot more inclusion and also respect for the work done in the humanities and social sciences, and with a broader AI literacy in society. So I'll stop here, and I don't know if we, okay, great. Go. Questions. Okay, yeah. Fantastic.
Might start with Dr.
Okay. Oh, thank you. All right. So I'll just read these questions. So I saw, so a question from David Lovell. In the context of ethics, what are your thoughts on the concept of explainable AI? What does it signify to you, and what bearing do you think it has on AI ethics? So I think, so one with explainability, I think sometimes people get maybe overly focused on the mechanism of, you know, how did the algorithm reach this decision, where I think often kind of a more, I don't know, meaningful thing to investigate is also just, you know, if you perturb the inputs, and if you, kind of perturb various variables, how does that change the output? And that can give you insight into the impact that the algorithm has on different variables. And I will say, so my original title had said interpretability is not enough. And that was, and I also think explainability is not enough. And the kind of my thinking there is often, so, this example of the woman with cerebral palsy who lost access to healthcare that she really needed. She's quoted in this article of saying, I wanted an explanation, and I demanded an explanation and they wouldn't explain to me, which I think is, is very, very real. But I think the layer under that was even deeper is really she wanted her healthcare back. Like she needed that healthcare, and I think really wanted or needed and deserved more power in that system. And so I think that ideas around recourse and contestability are I think even kind of deeper and more meaningful, because often when people ask for an explanation, they want that explanation so that they can find recourse or so they can contest a decision that's been made. I do want to recommend the work of Burke Uston on this. And so he has this idea of actionable recourse, and he uses an example in his research of an algorithm that's making loan decisions, and was saying, again, kind of, you can give people a statement, explaining like this is why your loan was denied. But he was saying the kind of even more meaningful and helpful question or information to provide them with is what can I do to get a loan approved? So not just like, why was I denied, but like, what could I change to get my loan approved? And I thought that was a great reframing. And also those aren't always the same thing. On the surface, they seem the same, but if you dig into the algorithm, sometimes those are different things. And so I think sometimes I'm now more interested in these questions around either actionable recourse or contestability of how can people kind of really push back against decisions that are wrong or harmful. All right.
One more question.
Oh, sure. So there's a question, can I ask, what does your model is controlling the next round of data you get cause flawed data? That's a great question. And it's, so it is a form of a flaw, but it's also, it's with a feedback loop where you're controlling the next round. It's really just that you're creating an outcome. You're not just observing the world neutrally. So, in the example of predictive policing, it's, you're not just observing. I mean, you might start at step 0 where you are observing like, okay, this is how many arrests have been in this neighborhood in the past, and this is how many arrests have been in this neighborhood in the past. But you very quickly, once you start making a recommendation of like, okay, let's send more police to this neighborhood and not to this neighborhood, you're controlling the future and kind of controlling, or maybe not totally controlling, but having a significant impact on how many arrests are going to be made next week, using the results of your outcome. And so it's, and then when you start treating, that data goes back into your algorithm, you're both kind of creating your inputs and your outputs, and it can become very circular. And so some of that's also just kind of recognizing the impact that our models and that our systems can have, that we're not just kind of neutrally observing this data, and to recognize no data is neutral. There's a whole history that already goes into step 0, the data that you receive, but that you can really be having a significant output impact. And so this is also, again with the YouTube example, it's hard because, this is something where it's, there's not like an objectively, like this is the objectively right recommendations that should be given. There's also a stance of kind of like, if the algorithm recommends something a lot, it is helping determine what ends up becoming popular and what doesn't, and that those decisions can have a huge amount of influence.
Hey, how's it going? Thanks very much for the talk. It's very thought-provoking. So you illustrated quite a few stark miscarriages of justice there. And it got me thinking about those old stories about genies, where you say something like, they trick you.
Sorry, old stories about what?
Genies.
Oh, genies, okay.
Yeah, so like you say, they say you have 3 wishes, and you say, okay, I wish for world peace. And so they go, okay, boom, the world is destroyed. There are no more humans. We now have world peace, right? You just didn't craft your wish especially well. How much of these types of miscarriages of justice are just that the objective function that we're supplying to the model that we're trying to train isn't kind of crafted perfectly? And is there something innate about AIs where this is always going to pop up, or can we find some sort of optimal objective function which is always going to debias our model that'll kind of solve it?
That's a great question. Actually, I wrote a paper that's kind of relevant to this. It's the problem with metrics is a fundamental problem for AI. So I think, so in many cases, yes, there is a poorly defined objective function that does exist somewhere in the model. Although this is not a simple fix for a few reasons. One is, I think in most cases, what you truly care about is often something that can't actually be measured. In many cases, it's a contested quality. So examples of this are, there have been many efforts in the US to want to provide a numerical score on how teachers are doing. And, it's like, how do you measure what's a good teacher? And then they end up using test scores because that's something easy to do. And, how have the student test scores changed year over year? And then, of course, you can see all sorts of ways why this is not actually a good measure. And this creates all sorts of problems. And there have also been kind of widespread cheating scandals where school administrators are altering student test scores. And so in many cases, though, you're like, yeah, that's a terrible objective function, but it's also, I don't know. In fact, I don't think that there is an objective function that would accurately capture is somebody a quality teacher, because that is this abstract contested ideal. So I think you have kind of many examples like that where you're like, yeah, that was a terrible, kind of a terrible proxy that you chose, but there isn't necessarily a good proxy. And you get into cases of Goodhart's law, where which states that when the when the measure becomes the target, it ceases to be a good measure. And so I think even if you start out with a measure that's okay, often if you overemphasize it and make it your target, it becomes less accurate and other things suffer. An example of this, and this is didn't even involve kind of computer systems, but the UK implemented something where they were going to publish surgeons' success rates, and that seems on the surface reasonable. It's like, okay, patients maybe deserve to know, like, what's the success rate of a surgeon. But then when this became a big deal, surgeons began turning down the most difficult cases because they didn't want to hurt their score. And so then you had people that couldn't find a surgeon that would operate on them who, very much needed surgery. And so that's something where, it's, on the one hand, it's like, well, I can see how it is helpful for the public to have this information, but then it's also like, oh, okay, now that you're overemphasizing it, it has started influencing behavior. So I think that's another thing that arises, even if you change your objective function to something better, that measure can become less good, kind of the more emphasis that's put on it. But great question. Thank you.
I have a question related to the beginning of your talk. So in the past, AI training, AI education was confined into university degrees. And nowadays, we have a lot of the platform like Fast AI, Coursera and so on, where you can get AI training through this platform without going to a computer science degree, a university degree. So with this respect, and you also having been an academic teaching in this field, what do you think the role of universities is in the teaching of AI?
Yeah, that's a great question about the role of university. And I should also say, I have experience. I have taught at universities. I've also taught at an in-person coding boot camp, which is another education model. And then, and I've taught in MOOCs, massive online courses. And I think everything has different pros and cons. Benefits of universities. I mean, so one, on a practical level, and I kind of wish this wasn't the case, but universities still are very, people look to them for credentialing, it's really kind of, going to a recognized university is what's going to help you get hired in many, many cases. And so I think that is significant. I think will continue to be significant. And I do think it's harder to or can be harder. I mean, there are, plenty of students that succeed learning online, but I think it can be harder to kind of prove that prove what you know and what you have to offer. Whereas I think universities kind of provide this very established, recognized signal around credentialing. I think for many people, myself included, do really like in-person interactions and like also smaller group interactions. And you can see this sometimes with online courses, like there are, people create in-person study groups to go through an online course together. But a lot of people, like I think that in-person interaction is very important to many people, including myself. And that can be missing from online courses. And there's also, for some people, I think a question of self-discipline. And so sometimes people need to feel like they are paying money and like have to show up at these places at these times to have, like I think MOOCs work well for some people that have a certain, inner drive and can push themselves. Yeah. And sometimes you can supplement that with a study group if you can create the pressure of like, oh, I owe it to my study group to show up. But that's something else that universities can offer. I mean, benefits of MOOCs, like the material in Fast AI. That's something when we set out to create it, it was like, this is the material I want but can't find anywhere. I think universities often have an overly academic focus. And so like when I was first getting interested in deep learning, this is like going back to 2013, I wanted something really practical. And so I have a PhD in math. I could understand the theory, but all I could find were, just these really theoretical papers. And I even went to talks and talked to experts, and they're like, I'd ask a practical question and they'd be like, oh, nobody's writing that down. Like, who cares? It's about publishing academic papers. And so I do like how I think MOOCs have pushed the field to be more practical and applied. You see this in computer science, particularly in the US. Like I studied computer science in undergrad, and I learned a lot of really theoretical things, and this is totally kind of standard. And then if you get a job as a software developer, there's like all this stuff that's not focused on in universities of like, oh, okay, like they didn't really cover, testing or a lot of kind of really useful things. And so I think MOOCs can help kind of bridge that theory to practice gap. Yeah, so I think both kind of have benefits, and I think MOOCs are opening material up to people that may not have access to an in-person university. I think MOOCs curriculum can often iterate quicker than universities. So I know, like in my experience working at universities, often the process of changing curriculum is a much kind of lengthier and more debated process compared to an online course where you often can put it out on new material or change the curriculum pretty rapidly. Oh, sure.
You talked about some of the predictive models used for unjust reasons in policing. Much of the work that we've done in university around predictive models looks at finding at-risk students. And research shows that if you use demographic information about students, you get more accuracy in terms of finding those students that are in need. And there's been a lot of debates in terms of should these models be colorblind or should they use these demographics? Part of the discussion about being, yes, you want to use it justly, but at some point it might become unjust. The other being, it's a duty of care that if you know these people are in need, then you should be helping them. Any thoughts on use of it for just reasons to begin with, which may at some point very well become unjust?
Sure. Yeah. So there's a few pieces there. So one, I do want to address that even if demographic information is not an input to your model, it often shows up as a latent variable, and so it's, I think, hard, if not impossible, to have a truly colorblind model, because often that those variables will kind of latently be encoded in other data. Yeah, as you said, the application I think really matters, and it's hard in the US. A lot of and so I'm more familiar with, I think, some applications in the US and the UK. Often they do kind of seem to have these punitive purposes where, it's not to offer someone a really helpful and meaningful service. And even when it's framed that way, often it isn't truly something that people want to opt in or participate in. You do raise, there is this issue around recognizing that kind of any data that you collect could be used by other people later for different purposes, and this happens a lot. And so there is also this kind of risk factor around even if you feel great about kind of the purpose that you're working on, that data could be, could be hacked or stolen, or just somebody could take over the project later or kind of make changes. And there are a bunch of examples of this where people kind of gather data in one context and then it ends up being used for a very different purpose later. And so that is important to think about, of how how that data could be misused. And that's also like it's a pretty fraught area, and that like I think there often aren't clear answers of like, okay, this is definitely the data you should like even something I believe the UN recommends not collecting ethnic information because it has been used, in multiple genocides where people kind of had ethnic information. But now there was a study that was really interesting of Rohingya refugees. And so this is the Muslim minority from Myanmar. And because the majority in Myanmar has kind of been trying to erase them, that in refugee camps, they're actually wanting their ethnicity on ID cards because they want to say like, we're here, we're not being erased as an ethnicity. And so even there, I think there's not a 100% clear, it's like, okay, here people are, like asking to have their ethnicity recorded, even though that had been this recommendation of like, okay, you shouldn't record ethnicity because this can be weaponized. So yeah, I think you do get into tricky questions. I think in the scenario you talked about, I would definitely be trying to include the perspectives of some of the at-risk youth and seeing like, what do they want and what do they think is ethical, and also like, what do they foresee could go wrong with this, and what would be particular pitfalls that they could warn you about. That's a great question. Oh, sure. All right, so this question says, how do you think we get to a world where we don't deploy machine decision systems without robust decision review and recourse mechanisms? Any thoughts on how we shift the Overton window? Not only acknowledge your system can be wrong, but ask how to plan for it. It's hard for consumers to demand these without having a mental model of what they need. And that's a great question. And it is tough. So I think that kind of robust decision review and recourse, those things are typically more expensive. And so there is an issue of, and I think that's something that's going to have to come kind of through more standardization and regulation, because I think it, will be hard for many companies to say like, okay, we need to add something that's going to require a lot more resources for us, and particularly if nobody else is doing it, and there you kind of have that race to the bottom situation where, okay, if we start offering a more robust decision review or recourse mechanism, does that mean that then we're going to not be able to compete with our competitors who aren't doing those things? It's hard because you also have to look at, so some of the examples I share today are, kind of where machine learning models were implemented in government services. And so, anything where you're talking about kind of the criminal justice system or social services, where people, aren't even opting in to using those, like those are kind of parts of society that are non-negotiable, in terms of whether you want to participate. So I do think that both regulation and then also standardization. And standardization is kind of where industries accept norms, even if they're not regulated, of, like this is what we're doing around something. There is something called the Santa Clara principles that were put together by a group of tech ethicists, and they are specifically around content moderation, but they call for timely and meaningful appeal is one of the Santa Clara principles, and I really love that. And I don't think any of the platforms are offering that on content moderation, but I would love to see them move towards that. Yeah. And then I guess I'll just say maybe one more answer to this question. I also think there's the need for more, and actually it seems like maybe there's a little bit more of this in Australia than in the US of also just integration between tech people and policy people. And so in the US, you have kind of not nearly enough technical knowledge in government, and also not enough technical people have policy or government knowledge. And there are some great programs that are working to try to address that and create more cross-pollination, but they are relatively small in the scheme of things. But kind of getting more collaboration between government and tech.
Rachel, thank you so much.
Oh yeah, thank you for having
We've had,
me.
no, not, of course, it's our pleasure, and to actually keep you here for 1.5 hours. So lots of questions, lots of interest from